Now, next up, we have a very famous name. I'm sure he was rather busy last week. Ángel Abbud Madrid, the Director of Space Resources Program at the Colorado School of Mines, with a very simple title, Why Space Resources? The Moon, Asteroids, Mars, and Back to Earth. Ángel, lovely to see you. Over to you.
Hello, Lisa. Great to see you again, even though virtually this time. It's also a pleasure to be at Luxembourg again. Let me see if you can have the slides. Okay. Yeah, and I'm just going to try one thing to see if my clicker works. It works. That's fantastic. All right. Let me just go back. All right. Take some time. All right. Very good. Well, so far we have heard various proposed space resource utilization scenarios. And by the way, it was a real pleasure to see the creative ideas from my dear former students from the University of Luxembourg. So well done, everybody. Now, all of these ideas have been about various destinations, and we will get to hear in a moment from Ben and Jerry, Ben Bussey and Jerry Sanders, on the specific plans that NASA has for the moon. But what I decided to do for my contribution to this panel was to focus on the long term and try to specifically address a question that is very commonly asked by members of the general public, people outside our space resources community. And that is a simple question that is, why? Why are we going outside our planet to a very challenging, inhospitable, and difficult place to extract resources? Don't we have all that we need here on Earth? What are the benefits that we can get if we go outside to obtain these resources? And I think that is a very important question to address, because we would like to have the support of the majority of the public as we embark on this very ambitious effort to go and extract resources from space. And hopefully we'll do it this time in an efficient, but also in a fair, responsible, and sustainable way. And it's also an important question to answer ourselves that worked on this field as we set up to have a goal in our efforts on an everyday projects in which we are all involved. So why? First, it's important to keep in mind that a resource has value by its utilization. We're not going out to just find an element for scientific interest or out of curiosity. We're going to find resources that can be of use to us. And from that standpoint, I think we can all agree that for the last 60 years, we have been using the first resource from space. And that's just simply the view from above that has given us weather forecasting, global communications, the possibility of pinpointing every location of the Earth with extreme accuracy, and even the possibility of monitor the health of our planet as we continue extracting resources from Earth. This is also the only commercial use of space to date. It is a healthy $380 billion a year industry based on communication satellites. But we can all agree that there are more resources in space than just looking at our Earth from outside. And here is where we go to our first step, and that will be talked about much during this conference, is the moon. The moon, in which we have, from remote sensing and from even samples that we have brought from Earth, we have identified a variety of important resources that can be utilized, such as minerals, or a variety of metals and non-metals like oxygen and silicon, and regolith, and actually also volatiles, out of which the important ones obviously are water, hydrogen, helium, and even the isotope of helium that has been mentioned before, helium-3. And all of these resources, as I mentioned before, have value because of their utilization. And the possible uses that we have identified is human consumables. How is that we going to have humans getting the oxygen and the water that they need in order to survive there? Also manufacturing. How can we use advanced manufacturing and use the metals and the regolith for spare parts and tools? Construction, habitats, landing pads, berms, roads, and everything that is needed. And obviously, propellant, and it has been mentioned several times. propellant that can help us not only to have the energy source that we have at the moon, but also we can start exporting that from a low gravity or a lower gravity body to other places and have those fuel depots in space that can then allow us to lower transportation costs, and with this, increasing the number of activities and access that we can have to space. But why? Why is that we want to do this? Why is that we want to go to the moon? Well, you know, it will allow us to stay there for longer than just a few hours as before, to finally have a permanent settlement there. And we can even use the infrastructure that we have developed at that point and what the propellant that we're using to keep going further. Like, for example, going to the asteroids that can have also many resources that can be of much use, you know, such as, you know, again, volatiles, water. We can have metals like iron and nickel, and the important noble metals like platinum group and gold and silver and all of those, and non-metals such as carbon and phosphorus for a variety of uses. We can use those resources for propellant. You can have hydrogen and oxygen that can be split into water that can be split into hydrogen and oxygen, but simpler than that, just heat it up and you have steam for propulsion. And if you heat it even more, then you get into a plasma, and even you have a possibility of ion propulsion. We can use it if we're going to have humans along the way to asteroids for whatever is needed for their survival, and also for manufacturing and construction. So we have reached now the asteroids, but why? Why is that we want to go to all these amorphous rocks that are floating around on the solar system? Well, you know that we have seen that it can be a source of propellant, and they can become a stepping stone to now use everything that we have developed to even reach what is the holy grail of exploration, and that is the planet Mars. And on Mars, be able to find a whole variety of resources that is even more abundant than in the other two destinations. Water that can be obtained in subsurface glaciers or from hydrated minerals that are in many places on the planet. We have all the metals that we mentioned before and the important non-metals too. We also have the regolith that can be utilized for a variety of construction and manufacturing applications. And we have an atmosphere which is quite different from the moon, in which now we have carbon, and the moment that you start having carbon, you start having hydrocarbons like methane and ethylene and plastics and everything that we use carbon for here on Earth. So the various uses there would be for, again, human consumables, allowing us to now be able to live off the land in another planet. We also be able, again, for manufacturing and construction, and also for propellant that we can use to hop around the planet to explore even further, but more importantly, to have the fuel ready so when we want to come back home. So great, we have reached the planet Mars, but why? I mean, why is that we want to do this and use all these resources? Obviously, we want to gather more information about another planet. We will be able to finally live in another planet. And like space agencies and commercial companies have very logically outlined, its moon, Mars, and beyond. But what is that beyond? Why is that we want to keep going further? And we will be able to do that because resources will enable us to have larger payloads, much more able instruments, and even learn more about the rest of the solar system. But here is where I will venture to say that the beyond is about bringing all the benefits from space resources to our planet Earth. And here is where we can start seeing that, yes, dozens, hundreds, maybe thousands will make it to the moon and Mars at some point. But let's face it, the majority of us, billions of us, will remain on Earth, the planet in which humans evolved and the one in which we were designed to operate efficiently. So what we have done at this point is just extended the space, literally the space in which we can obtain more resources for our survival. This is exactly what we have been doing on Earth for thousands of years, being able to use these resources to keep expanding, to keep allowing us to survive, and not only that, to increase or better the conditions of life here on Earth. And so what is that we can benefit by using the resources in space? Well, one thing that I mentioned already is just knowledge. Gaining knowledge of the solar system or whatever is happening out there usually translate in very useful applications here on Earth. But more than that, by developing this infrastructure of propellant in space that can lower the access to space, that can allow us to have much more able communication satellites or GPS systems that will be able to cover the entire planet, to be able to be refueled and moved around at a minute's notice. And so that will really improve the type of communications that we have on Earth. We will be able to have not just one, but several space stations from space agencies, but also commercial companies, the private sector, that would allow us to manufacture goods in a very unique environment of ultra-high vacuum, of low gravity, that can give us products that we can bring back to Earth from our own benefit. And yes, even the possibility of tourism for people to go out and experience Earth from outside and give us a different perspective of our planet. We can start building large structures out of resources in space that at some point can utilize the inexhaustible resource that is solar energy and be able to beam it back to Earth in microwaves and lasers to specific points on Earth so that we can have energy 24/7 without worrying about clouds or plastering the entire planet with solar panels and solve many of the energy needs that we have in our planet today. We can also use large structures for just monitoring our climate, and in the future, if it's deemed that it's not harmful, even provide some climate management to help some of the climate change problems that we have at this point. If deemed economically feasible, and if for some reason we are starting to dig too deep for resources here on Earth and causing much environmental degradation, we can even start importing raw materials such as metals and even helium-3 that can be served as a clean energy source for fusion if we get fusion under control here on Earth. And without noticing it, by doing all this and other things, we'll be developing technologies that are quite advanced because they have been designed for the most extreme environments that one can find, and also to be used with much less power and with much lower mass. And all of these things will filter down into our uses here on Earth, exactly like spin-off technology happened when we started going into space more than 50 years ago. And at this point, what we have done is that we will have been created new industries that we cannot even think of at this point. Industries that now will be creating new and exciting jobs, focusing on some of the most extreme and more difficult and challenging problems in engineering that we have faced. And that will bring new exciting opportunities. In fact, we are already seeing that dozens and dozens of companies have sprang out in the last few years, each one of them trying to find an opportunity in this new phase of space, positioning themselves on what we call the value chain of resources, the ones who will be prospecting or excavating or drilling or extracting or refining, or even looking at all the infrastructure, power, communications, transport, and seeing how is that they can contribute in all of these areas. And so it's good to see the excitement from the private sector. In fact, look at the Space Resources Week at Luxembourg right now. There's more than 1,000 people that are tuning up to see how is that they can get involved in this field. And let me tell you, and probably this is a bad thing, but none of us will make it to Mars. But all of us are extremely excited of how is that we contribute to something that is larger than ourselves, that it will actually be probably longer than our professional lives, but we will know that it's something that will benefit all of us. And here's where resources will play a key role. Space resources is not a destination. It's not a flashy the headline of some planet that we have discovered or a moon of Jupiter and Saturn. In fact, space resources will be a very mundane activity, just like we have here on Earth. But it will be a big enabler for all of the great things that we can do in space. On Earth, we don't think much about resources. They run underneath everything that we do without seeing it, but they're their main engine of our technological society. And so it will be with resources in space. So next time that a relative, a friend, or a person right next to you on the bus or the airplanes ask about why is that we're going outside for resources, A possible answer here will be that we are taking the steps to start identifying, extracting, and utilizing resources in cislunar space on the moon, asteroids, and Mars, so that we can bring the benefits to all of us here on the good Earth. Thank you much.
Abbud, thank you so much as always. I'm looking online and there is so much praise for you, people who have been under your spell as students or various other things. Enchanting, exciting, and et cetera, et cetera. A couple of questions as well. Mel, have you got a question for Angel?
Yeah, just a quick one. Thank you, Angel, as always, an inspiring talk. I was wondering if you can see synergies or feed-forwards between the different destinations in terms of the technology that will be required to extract the resources.
Absolutely, absolutely. And that is why we're going one step at a time. We will see that right in a few minutes about the plans about going to the moon, in which you will be extracting resources with drills and excavation tools. We will be extracting probably water ice from repellent shattered regions, or extracting oxygen from the regolith, with very similar technology that will be needed for example, asteroids, in which we may be using radiation or concentrated solar to extract them, or Mars, in which we will be using similar drills. So there is a connection between all of these destinations. So that's why it's important to go step by step, try to make sure that everything works fine in remote control and then autonomous systems as we keep going further and further for extracting resources.
That's super. I wish we had more time, but trying to keep to time for the next speaker as well. And hopefully next time for this event, you will be here in the flesh. And just to tell you, last time it rained so much during that week, we actually have a good day, or at least we did before I entered the building here. So hopefully next time you come, you can have some weather that's akin to Colorado. Thank you, Akan.
I'll see you there, Lisa, next year.
Hopefully.